Now that we know how to determine the number of triangles, we're going to apply it to a few problems. So determine whether each triangle has no solution, one solution, or two solutions. Then we want to solve the triangle. We'll round side lengths to the nearest tenth, and we'll do angle measures to the nearest degree. So starting with letter A, we first need to determine how many triangles are we dealing with. And in my triangle, I'm given an angle measure of 105. So I know I'm dealing with an obtuse scenario. I'm going to try and draw my triangle like this because I don't know if I really have one yet. But I do know that my angle measure down here is 105. The side length across has to be 9 because capital R goes with lowercase r across from the side. And then the other side length S, that's 6. So this would be the angle measure T, and S would be somewhere down here if we make a triangle. Looking at our scenario, this 9 represents A because it's across from our angle measure that we know, and this 6 would be B. So in our case, underneath of an obtuse triangle, we say that A is bigger than B. Going back to my chart, under an obtuse angle, if A is bigger than B, we get one solution. So now I can draw in my triangle all the way. Put S there. And now we can solve our triangle knowing that we have one triangle. So now we want to find the measure of angle S, the measure of angle T, and side length T. We have to start with the measure of angle S. If we're going to use the law of sines, which is what we're trying to do since we don't have right triangles, the only angle that we can solve for first is S. So we're going to say sine of S over 6, because that goes across, is equal to sine of 105 over 9. You can cross multiply if you want, or since your variable is S in this case, I'm going to get rid of 6 by multiplying by 6. So I have sine of S equals 6 sine of 105 over 9. And then to get sine away from S, I'm going to take the inverse on both sides. So sine inverse of everything that we see over here. And now you may take out your calculators, and we'll plug this in. So second sine, 6 sine of 105, close it off, divided by 9, close again, gets us an angle measure of approximately 40 degrees. We're going to say angle S is 40 degrees. That helps us to find angle T now. We know that this is 40. We can just take 180 minus 40 minus 105. I'm going to do that. 180 minus 40 minus 105 gets us another angle measure of 35. And then to solve for side length T, we can also use the law of sines. So we're going to say sine of 40 over T equals, and then you can use either scenario. I'm going to go back to the original, sine of 105 over 9. I'd cross multiply this time, getting us T sine of 105 equals 9 sine of 40. Divide by sine of 105. T equals 9 sine of 40 over sine of 105. Calculator work again. 9 sine of 40 divided by sine of 105. Gets us approximately, it's going to round it all the way up to 6 this time. And that's how you do it.